All right, welcome back. Where did we leave off? I defined the distinction between a class and an object. A class bundles up data and functionality, and an object is an instantiation of that class, right? So the blueprint and then the house that you physically build from the blueprint. Object, class. Okay. We started in the last segment talking about this ball object, and I told you that this is a class. I instantiated it a few times. The data stored is the XY location of a ball, the velocity of the ball, and we saw one functionality associated with it, which is called update position, which means I can move the ball according to the velocity. Okay. Now, I didn't tell you how to build an object. I didn't tell you how to define those functions. I didn't show you any of that, and that's what we're going to do right now. Okay, so here is the class definition of type ball. Okay, so there's a lot going on here, so let me just break it down a little bit. So up top is the usual. I'm importing the draw because I'm going to do some drawing inside of this ball class. I'm going to build a canvas, again, because I'm going to do some drawing. And I've defined some global variables, earth and ball radius. Now you may remember, and by the way, notice I've done in all caps here, which is sort of my convention for global variables, to remind me that these are global variables. Now you may remember a while back I said, you really shouldn't use global variables. I'm doing this here because it allows me to simplify this code a little bit. So while I don't think that this is the best programming style, it allows me to make this code a little bit cleaner for the purposes of explaining our first class. Okay, now I would like to build a class of type ball. Remember, again, the class is not the thing itself. We will have to instantiate it by calling a constructor, which I'm going to describe to you in a little bit. Okay. The way you define a class is a few things. First of all, you have the keyword class and then the name. Now, by convention, you don't have to, by convention, classes are always capital letters. It just sort of helps us keep track of what things are by doing that. There's that same colon operator that we've seen over and over again for functions, while loops, if statements, etc., etc. And then the body of the class, everything that we are going to do is indented. Okay? Now, notice that the only thing this class has is a bunch of functions. This weird looking function, underscore, underscore, init, underscore, underscore. We'll get back to it in a little bit. And then update position function. Oh, we saw that before. That's the function that updates the position based on the velocity. Here's another one, update velocity. Here's another one called animate step. And here's another function called draw. So this class has 4 pieces of information it's storing plus another one, so that's 5, and I'll get to what all these mean in a second. It has a constructor, that's this thing right here, which I'll come back to and talk about in a minute, and then 1, 2, 3, 4 functions. So data, constructor, and functionality. Okay? Now, what should the functions be? That's up to you. What do you want users to be able to do when you've built this ball class? I wanted you to be able to move it around and draw it, which is why I'm giving you this functionality. You may want something else. That's up to you. Okay. All right, so now let's sort of dig into these various functions. So again, you've got the class keyword, the name of the class, typically capital letter, colon, body, which are just going to be a bunch of function definitions, one of which is very, very special, which is the constructor. So let me blow that out here and let's talk about that. So remember again that capital B ball is the name of my class. That was the name of the class there. When I want to build an object of that class type, I call the constructor by just using the name of the class, paren, paren, and then whatever data is expected to be passed into the constructor, which I'm going to show you in a minute. Every single class that has ever been built in Python has at least one function which is called a constructor. Its job is to allocate memory, assign data, and return an address. We saw that in the previous video segment. The constructor must have the following name. You have no choice in this. Underscore, underscore, init, underscore, underscore. I know it's weird. It's just a convention. And it says the first function in your class must be a constructor. Why? Well, if you don't have a constructor, you don't have an object. And so you can define anything you want, but if you can't instantiate it, this is just a waste of time. And we force the use of that name because we know that we're going to call the constructor with the name of the class. And this way, Python knows to go look for the name of that function. You can't just call it whatever you want because how is Python going to know what the constructor is? And so we force you to call the constructor underscore underscore init underscore underscore. Good. All right, so here's what happens. You call the constructor for an object. It reaches into the class definition called ball. It goes into the body and it finds the function with that name right there. That has a number of parameters. This is weird self thing that you're seeing everywhere. I'll come back to that in a minute. Start x, start y, start vx, start vy. That looks like my x, y, vx, vy. I've changed the names here a little bit because I couldn't put in the start in there. So that's start x, start y, start vx, start vy. Okay, I just wanted to make it a little bit more compact. And there's this, so that's the 4 that we saw earlier. And there's this 5th one, which is color, but then there's like an equal blue in there. So what is this little thing doing right here? When you pass parameters to functions, not just constructors by the way, any function you want, you can assign a default value. And the way you do that is, this function says, you got to give me an x, y, vx, vy. I must have that, otherwise I can't create one of these things. Okay, that's fine, that's my responsibility. And then you say, look, optionally, you can change the color of the ball, or you can leave it my default value. And by writing color, which of course is the name of the variable, equals blue, then what happens is if you pass in a parameter here in this 5th position, that will be color. And if you do not, then Python will simply use blue as the color. So it's a nice way of creating what are called optional parameters that can be passed in. And notice, by the way, that this start x, start y, start vx, start vy are right here. Start vx, start y, etc., etc. And then color is right here. Okay. Now, what is this self thing going on here? Okay, so this is one of the biggest sources of confusion when we first start talking about objects and classes, and it's just because the syntax is weird. Conceptually, this is a very simple idea, so let me go ahead and start by explaining conceptually what's happening here. What did I say a constructor does? Allocates memory, shoves a bunch of things in that memory, and hands back the address to the object that it just created to you, and then you can do whatever you want with that. Here I'm assigning it to the variable myBall. So notice that this constructor doesn't seem to be allocating memory. I don't see that. Where is that being done? It's obviously being done because this works, but it's being done behind the scenes. And so what Python does is as soon as this constructor gets called, behind the scenes it's allocating some memory. It knows that it's going to store x, y, vx, vy in color, and it's going to now take the parameters that were passed to it, those right here, and store them into the object. Well, where is the object? It is self. Okay? So self is the name of a variable that init will assign to that address right there that it created for you. Okay? So just think of self, and by the way, self in every single function that you define in a class, from the constructor down to all the other auxiliary functions, must have the first parameter be self. Okay? And it's weird because when you look at this, I already told you that this function calls this function, but there seems to be a mismatch. That 10 is this x. So this is in here just because Python is going to populate it for you. When it allocates memory and gets an address, it shoves that address right there. Why do I need that address? Well, what's the rest of the constructor's responsibility? Its responsibility is to populate this with data. Where is it? How do I have access to it? So the variable self is the address to the object that Python created for you. And now I can say, reach into this object that you just created to me using the variable self and populate x, y, vx, vy, x, y, vx, vy, and color with whatever was passed in or the default variable. All right, good. So that's the constructor. Every single class, every time you define a class, you must have a constructor. First parameter must be self. Everything else is whatever you want to pass in. And all you then have to do is say self dot whatever you want your variable name to be whatever you want the data initialized to. Okay, so that's a constructor. We're going to see lots of examples of that in the coming lectures. So this thing right here then, there's essentially an implicit return in the constructor, by the way, which says return self. It's not in there explicitly, but it is. And then my ball is now that thing right there, which is the object that was just created for you. Now, I want to update the position of this ball. Remember, we did this in the previous lecture. So how do I do that? I take the current XY position, I take the velocity, I multiply it by the time step, and I get a new XY position. This is in pixels, XY. Velocity is pixels per second. Tell me how much time has elapsed, and I will do some work for you. All right, so let's go look at that function. So again, my ball is the object that I just created. Yep. Update position is a function in the class definition. It takes as input one parameter time step, which is that 0.1, but there's that self again. See it right there? So what's going on? It's the same thing as the constructor. This function has to do what? It has to reach into this one particular object. No other object that's of type ball, because there can be any number of them. It needs to know who this is. How does it know who this is? Well, it's my ball. Yeah? So what's happening here, and this is just syntactical, is that the address, my ball, when I call update position, gets shoved into that self. Exactly like the constructor. The constructor created an object for you, had an address, shoved that address into the variable called self, and then you got access to that. Good. So my ball address gets shoved into self. Time step parameter 0.1 gets shoved into that parameter. And now what's my job? My job is to update the x position based on the velocity and the y position based on the velocity. All right, let's go ahead and do that. Self is this thing right here. I just told you that. That's what's being passed in. So I'm going to reach into the x parameter. I'm going to take the time step which was passed in, multiply it by the velocity. So now I've got seconds times pixels per second. That gives me pixels. I add that back to the current x position, and then I reassign the x value. And then, of course, the same thing for the y. You can think about this, and really this is just syntax. That's all it is. You could have imagined that the syntax was a little bit different. That I could have said, update position with my ball and 0.1. That is, pass in this object, pass in a time step, and then manipulate the data associated with that object. That's basically what you're doing, but we just have a slightly different syntax because of this dot notation. The function update position is not known. It's only associated with an object. So we say, I have an object. There is a functionality associated with it called update position. I want to update the position not of the class, but of that object. That object is stored at that location. I'm going to shove that location into self, and then I can operate on the data associated with this particular object. So whenever you see self dot, all you're doing is saying, I am reaching into one specific object. What object? Well, whoever called me. That's it. Okay, good. I'm gonna switch over to Jupyter Notebook in a minute and run through some code and show you this thing actually running, and we'll talk some more about the constructor and these functions just to make sure we really understand them. Let me just mention one more thing about classes and objects. Here, for example, I'm calling the ball constructor with xy and vx, vy. And one of the things we've done up until now is we've just print stuff. And the reason we print stuff is that it's a nice way of seeing what's happening behind the scenes. And I just want to mention that when you print an object, you get this weird looking thing. It says ball.ball instance at blah, 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 whatever that is. I don't know what this means. So all it's doing, this by the way is the address. It's a hex number, not like a 3000 like I was showing you before. And this hex number is just an address. And so when you print a ball, it doesn't mean anything. Well, why? Well, what is a ball object? It's got a bunch of data. It's got a bunch of functions associated with it. What does it mean to print it? And so if you don't tell it what it means to print it, Python just says, look, this is some object at some address. And that's not very meaningful. So if you want to be able to print out some information about your object, you have to define the function yourself. And here's what it looks like. You define a very special function called underscore underscore str underscore underscore. This sounds a lot like the init function, right? That's the constructor. And there is a function called str. It takes a single parameter self, same thing. That's going to be the address of the object that called this print statement. And then you return, not print. This is really important. You're not printing. You are simply returning a string that you want to be printed when the print of an object is called as I did here. And here I'm just going to print the XY location. Could have been anything. How do I get the XY location? Reach into the object, grab the X location, convert that to a string. String concatenate that with reach into the object, grab the Y coordinate, convert it to a string, and just return that. Okay? So you don't have to have this. Nobody says you have to have a string function. You have to have a constructor. But if you want to be able to debug your code, which is often nice, with print statements, which is often nice, just create one of these little underscore, underscore, str, underscore, underscore, and return. Don't print. Your job is not to print, because notice here when I call print B, what Python says is, B is an object. What does it mean to print it? Well, let's go find the str function associated with the object. That will hand me back a string. Take that string and shove it right there, and then that will get printed out. Okay, good. All right, at this point what I'm going to do is I'm going to stop the video and I'm going to switch over to Jupyter Notebook and we're going to run through some of this class ball and I'm going to show you executing a little bit of code. So I'll be back in a second with that video. Okay, so let's go ahead and look at this object a little bit more carefully and review a few things. So let me just start with the obvious thing. We're going to import a little bit of information for the drawing and for the randomization. This again is my class, and you can see here I've just put this in a cell. You can of course import this from a separate file. You can create a file called ball.py and then import the class from the file itself. This of course is the constructor. So you see class ball colon, and then everything in here is function definition. That's my constructor, underscore, underscore, init, underscore, underscore. Here's my update position, update velocity, animate step, and draw ball. And I'll go through these in a little bit more detail in a bit. Let me just remind you again that every function, the constructor, this function, this function, this function, this function, and if I had a print function or an str function, must have a first parameter be self. What is self? It is going to store the address of the object that was either created for you in the constructor or was being used to call this function that's already associated with an existing object. So that self is simply the address of the object that has been instantiated. Good. Now, this constructor takes as input 5 parameters, one of which is optional, x, y, vx, vy, and there's my optional parameter, which I've defaulted to blue. So if I pass a color in here, it will be used, and if I don't, it will not. Notice that I have x, y, vx, vy, and color are the data associated with this particular class. They're being instantiated to whatever parameters I called in. Notice, by the way, that these are different parameters, but names, but I don't care. This is going to be just some number, some number, some number, some number, and some string. These are the names of the parameters being stored. They don't have to be the same. This is just some local parameter, and this is what's actually being stored inside of the object. So again, what does the constructor do? Allocate memory. Shove that memory address into self. Initialize data, and then return that address. There's no explicit return, but of course it's there, back to the whoever called the constructor. I call the constructor by simply calling the name of the class. Now, I've got a couple of functions here. Let me go ahead and evaluate this so I don't forget to do that later on. I've got a couple of functions here. Update position, you've already seen that. It takes the x location and adds to it how much time has elapsed times the velocity, same for the y. I also have an update velocity, which we'll talk about in a second. So what am I doing here is now, so if a ball is moving and nothing acts on that ball, then all I have to do is know the ball's initial position and the velocity, and the ball will simply move in exactly the same way. But if there are external forces like, for example, gravity operating on the ball, then the velocity will change over time. What do I mean by that? Well, if I throw a ball into the air, over time, gravity slows that object down and then eventually pushes the ball downward. And so I have a function here called update velocity that takes the current velocity, not the y position, but the velocity, and updates it based on gravity. Gravity, of course, I defined up top to be minus 9.8 or whatever. Actually, sorry, I define it right here. And so this is minus 9.8 meters per second squared times time step, which gives me meters per second, which of course is what I'm going to update my velocity by. And then I have this other function called animate step, which you can see is just a call to update position and update velocity. So this is just a way of bundling up two things. On every iteration, two things can happen. The ball can move based on its velocity, that's update position, and the ball's velocity can change because of gravity. And then I just have a draw ball function where I append to this D, that's my canvas down here, a circle at position X, Y with a radius and then a fill color. Notice here that this radius is a global variable. So I could have had that be part of the data. In fact, that would have been a perfectly logical thing. In this class, however, I decided that I want all the balls to be exactly the same size. I didn't want the user to be able to change it, so I just made it a global variable. Is that right? Is it wrong? Nobody's to say. That was just a design decision. Notice here that whenever in this function I want to draw this ball's x at position x, y with a certain color, and the way I access that is through self. Self here is the address of the object, and I have to know which of potentially many different objects that have been created from this foot blueprint I need to access. So anytime we're accessing data associated with an object, here, 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 and here, you have to go through that self variable, which of course is just the address of the object that was created by the constructor. All right, so we've seen most of these, but let's just go through it again because I think it's a good exercise. So again, I'm going to use some global variables just because it's simplified the code up top. I'm going to create a canvas. I'm going to define what gravity is, minus 9.8 meters per second squared, and then the ball radius to be 10 pixels. What is this line right here? It is a constructor. That's the name of the class, x, y, vx, vy. Remember again, I can directly access elements of the object, x, y location, by using the dot notation. Tell me what the object name is, and then reach in and grab it. Same thing and then I can update the position here using the dot notation, call the function that of course is defined up top, update position. Animate step, same thing. I've got an object, I'm going to animate the step, and I can verify that all of these are being updated appropriately. And then of course I can just draw the ball. And let me go ahead and just evaluate this code so we can see what happens. So here are the coordinates of after I've updated position and velocity, and then I've defined a second ball of color red. So here you can see I'm overriding the default color at a different location, -5, -5, different velocity, and then I'm going to draw the first ball, draw the second ball, and they show up like this. Notice, by the way, it looks like there's only one draw ball function. And there sort of is and there sort of isn't. So let me go back up to the draw ball function here for a second. In the class definition, there is one draw ball function. But when I instantiate two different objects, one right here and one right here, you can think about that blueprint getting split. So there's now a draw ball function associated with the ball 1 and a draw ball function associated with draw ball 2. And really, that's not quite true. It's not literally like there's two functions, but notice here, this is where you really see the importance of the self. When I call draw ball, which object do I want to change? There's two of them now. Well, it's whatever the address is of the calling function. So when I call ball 1, self gets instantiated with the address of ball 1. When I call ball 2, this self gets instantiated with that object's address. And so then when I'm tapping into X, Y, and color, I'm looking into different objects. Okay, good. All right, so let's go ahead and just run this little bit of code and see what happens, and then we'll go back and look at it. Nice, so you saw two balls, one red, one green. And what did you see there? It looked like it was initially going up and then eventually sort of peaked and then went down. That was gravity acting on the ball. So let's go ahead and look at the code that did this. So again, define a canvas, define gravity, define the radius, make two balls, ball 1, ball 2, calling the constructor, x, y, vx, vy, x, y, vx, vy. One ball is green, one ball is red. Constructor gets called. I initialize all that data, and I hand back an address, and now I have two balls. Okay? I've got now, notice that this function is outside of the class. It has nothing to do with the class. This is my function that I've just defined. And what is it going to do? It's simply going to call draw ball on ball 1 and draw ball on ball 2 and then return D, which of course is the canvas. So now let's go ahead and look at this little body of code. So I've got a little for loop for 100 iterations. I'm going to build a canvas. There it is right there. Here is our usual animation loop. So with draw dot animate Jupiter draw frame, that's my function up here. I've got a delay, how much do I wait between frames, and I call draw frame. And then inside, so that what does that do? That calls this, it draws the current ball at its current position with its current color. And then I'm going to animate step with a time step of 0.1. Remember what animate step does. It looks at the current position and the current velocity and says, okay, where should the ball be at the next moment in time, and what should the velocity be in the next moment of time with gravity acting on it? I come back up and I do that over and over and over again, and on each step, the ball is moving and the velocity is changing. So again, what's happening here is, let's just run it one more time. The ball initially is going, one is up to the left, and one is up to the right. Over time, gravity overtakes the initial velocity and drives the ball off the canvas. And here you can really start to see the power of the abstraction of an object. So imagine I didn't write the class, and imagine I didn't even know how to write the class. I don't know how to update the position of the velocity. I don't know what gravity is. But somebody told me that they built a ball class. Somebody told me that all I have to do is specify the position, the velocity, and the color of it. And then I will tell you how to draw it. I will tell you how to animate it. And then all you have to do is write this little bit of code right here. This is it, 10 lines of code. And you can create a physical simulation of a ball being thrown in the air and gravity acting on it. And you don't really have to know anything, right? All you have to know is that there's a function called animate step, and it takes a time step parameter, and that you can draw the ball, and that this is the constructor. And therein lies the power of, one of the powers of these objects and classes. They abstract out all the functionality and how things are being done. But you also see the power in that I can now not just create one or two, I can create 100 of these. And once I have that blueprint, I can go crazy. I can keep building more and more of these things and build more and more interesting simulations of how balls bounce around, for example, a chamber, which we're going to see in a little bit. All right, this is our first object right now, and we're going to be talking a lot more about these. So if not everything is clear, don't panic. We're gonna keep talking about this. Don't get confused by the syntax. There's all this syntax going on here, but try to learn the core concepts here, and then the syntax will come along as we do more and more examples. All right, I'm going to stop here, and then we'll pick it up in a little bit when we get on to the next segment.